On the first day of September in the year 1859, telegraph wires across the world burst into flame, and the operators kept sending messages with their batteries unplugged, powered by a fire in the sky. That was the largest solar storm in recorded history, and it struck a planet with almost nothing electrical to break. We are not that planet anymore. In this video, I am going to show you why the very same storm today could switch off the power for tens of millions of people, not for hours, but for months, and why the clock says we are overdue. Stay with me to the end, because the most frightening part of this story is not what the sun can do. It is what we built underneath it. Tell me in the comments how long you think you would last if the power went out tomorrow and never came back on. Subscribe so you are not in the dark when the next warning comes. And now, let's get into it. On the first day of September in the year 1859, the sky over planet Earth stopped behaving the way the sky is supposed to behave. People in Cuba looked up and saw the heavens glowing blood red. Gold miners in the Rocky Mountains rolled out of their tents in the middle of the night, lit their stoves, and started cooking breakfast, because the light pouring down on them was bright enough that they were certain the sun had already risen. In some towns, you could stand outside at 2 in the morning and read the small print of a newspaper by a light that came from nowhere on Earth. And in telegraph offices all across the world, the machines began to do something genuinely frightening. They threw sparks. They caught fire. They shocked the operators who touched them. And then, in a detail that still sounds like fiction, some of those operators disconnected their batteries completely and discovered that the machines kept sending messages anyway, powered by an electric current that was flowing through the wires straight out of the sky itself. What those people were living through was the largest solar storm in recorded human history. We call it the Carrington Event, and for the next hour, it is going to be the single most important thing you have ever heard about. Because the storm that lit up the sky in 1859 is not a closed chapter in a history book. It is a warning. And the reason almost nobody treats it as a warning is the same reason it was so harmless the first time. In 1859, the most advanced piece of electrical technology on the entire planet was the telegraph. A storm that could set telegraph wires on fire had almost nothing else to break. There was no power grid. There were no satellites, no computers, no internet, no hospitals running on electricity, no water arriving through electric pumps. The storm hit a world that was, by pure luck, almost completely immune to it. We do not live in that world anymore. And that single fact is the thread that runs through everything I'm about to tell you. The sun has not changed. The sun is still capable of doing exactly what it did in 1859, and worse. What has changed is us. In the span of a little more than a century and a half, we built an entire civilization on top of the one thing a solar storm attacks. And we did it without ever really asking what would happen if the sky caught fire again. The man who gave the event its name was an English astronomer named Richard Carrington. On the morning of September 1st, he was doing something he did almost every clear day, projecting an image of the sun onto a screen and carefully sketching the dark sunspots crawling across its face. And then, without any warning, 2 points of blindingly bright white light erupted directly over the largest group of sunspots. Carrington was so startled, he actually ran to find someone else to confirm he was not hallucinating. By the time he got back, barely a minute later, the brilliant flash was already fading. He had just become the first human being in history to witness a solar flare, a sudden, violent release of energy on the surface of the sun equal to billions of nuclear weapons going off at once. Another observer, an amateur named Richard Hodgson, saw the same flash independently from somewhere else in England, which is part of why we trust the account so completely. What Carrington could not see was the second act. Along with that flare, the sun had hurled a colossal cloud of magnetized gas out into space, a coronal mass ejection, a billion tons of electrically charged particles traveling at a speed almost impossible to imagine. Normally, a cloud like that takes 2, 3, even 4 days to cross the gulf between the sun and the Earth. This one made the journey in about 17 and a half hours. It arrived almost a full day ahead of schedule, and we now understand why. An earlier eruption, a day or so before, had already blown through the space between us and the sun like a plow clearing snow off a road. The second cloud raced down that cleared path almost unopposed and slammed into the Earth's magnetic field at full speed. When it hit, it poured an ocean of energy into the upper atmosphere. That is what lit the skies on fire from the poles all the way down to the Caribbean. But the same physics that paints an aurora across the sky also does something far less beautiful. A storm like that reaches down and induces electric currents in the ground, and in anything long and metallic sitting on the ground. In 1859, the only long metallic things we had strung across the continents were telegraph wires, and so the storm dumped its currents into those wires, and the wires sparked and burned and kept chattering with no batteries attached. It was a preview on the only stage we had built of what this kind of storm does to human technology. It seizes our wires and turns them against us. Now hold that image in your mind, the telegraph office full of sparks, and ask yourself a simple question. If a storm in 1859 could do that to a few strands of wire connecting one town to the next, what would the very same storm do to a planet wrapped, end to end, in millions of miles of high voltage power lines? What would it do to a world where every drop of clean water, every dollar, every hospital, every gas pump, and every conversation depends on electricity that never, ever stops flowing? That is not a hypothetical question. The sun has already answered it once, in our own lifetime, and we only avoided catastrophe because of where the Earth happened to be standing on a particular day. To understand how close that call really was, you first have to understand exactly what the sun is capable of throwing at us. And that is where this story turns next. The sun looks from here like the most stable thing in our lives. It rises, it sets, it warms the morning. It is the very definition of dependable. But that calm yellow disk is a churning nuclear furnace wrapped in a magnetic field that is constantly twisting, knotting, and snapping. And when those magnetic fields snap, they release energy on a scale that has no equal anywhere in our daily experience. To understand why we are overdue for a disaster, you have to understand the two weapons the sun carries, because they are not the same thing, and the difference between them is the difference between a light show and a blackout. The first weapon is the solar flare. A flare is a flash of radiation, light across every wavelength, including X-rays, released when the sun's magnetic field reorganizes itself violently. That radiation travels at the speed of light, which means when we see a big flare, its effects are already arriving. There is no warning time at all. A powerful flare can ionize the upper layers of our atmosphere within minutes and black out radio communications across the entire sunlit side of the planet. Pilots lose contact, ships lose signals, and emergency radios go quiet. But here's the reassuring part, and I want to be honest with you about the reassuring parts, because this channel does not deal in pure panic. A flare's radiation, as disruptive as it is to communication, is mostly stopped by our atmosphere before it reaches the ground. A flare alone, however bright, is not the thing that ends modern civilization. The second weapon is the one that keeps the people who study this awake at night. It is the coronal mass ejection, and it is a physical object, a cloud of billions of tons of charged plasma threaded through with the sun's own magnetic field, blasted off the surface at speeds that can exceed several million miles per hour. This is the cloud that Richard Carrington never saw in 1859. Unlike a flare, it does not move at the speed of light. It takes hours or days to cross the distance to Earth, which, as we will see, is the only thing that gives us any warning at all. And unlike a flare, it is not stopped by the atmosphere, because it does not attack the atmosphere. It attacks the magnetic field of the entire planet, and through that field, it reaches all the way down to the ground. Whether a coronal mass ejection ruins your year comes down to one detail that sounds almost too small to matter. It is the direction the cloud's magnetic field is pointing when it arrives. The Earth's own magnetic field points very roughly in one direction. If the incoming cloud's field points the same way, the two repel and the storm is shrugged off. But if the cloud's magnetic field points the opposite way, southward, the two fields link together like a zipper closing, and the door to our magnetic shield swings wide open. All that energy comes pouring straight in. The terrifying truth is that we usually cannot measure which way that magnetic field is pointing until the cloud is almost on top of us. The sun can fire a 1 billion-ton cannonball at the Earth, and we cannot know if it is going to bounce off or punch through until the very last minutes. Hold on to that, because that 30-minute knife edge is going to come back later, in a way that matters enormously. When a fast cloud arrives with its field pointing the wrong way, the result is a geomagnetic storm, and the same chain of events that played out in 1859 repeats. The upper atmosphere lights up. The planet's magnetic field shudders and heaves. And down on the surface, in the rock and soil and salt water, electric currents begin to flow that should not be there. Scientists have a name for these currents. They call them geomagnetically induced currents, and that mouthful of a phrase is, quietly, the most dangerous thing in this entire story. Because those currents do not care whether they are flowing through 1859 telegraph wire or through the backbone of a 21st century power grid. They will flow into whatever long conductor we have laid across the ground, and we have laid down a great deal more than telegraph wire. To measure how big these storms can get, scientists use an index that tracks how badly the Earth's magnetic field is being pushed around. You do not need the units. You only need the comparison. The storm that, as we will see in a moment, knocked out the power for millions of people in a single winter night, registered at a certain level. The Carrington Event, reconstructed from old magnetic records in India and from chemical fingerprints frozen into polar ice, registered at somewhere between 1.5 and 3 times stronger than that. So when I tell you a modern storm took down a major power grid in 92 seconds, I need you to remember that the Carrington Event was not that storm. The Carrington Event was much, much bigger. And it gets worse. Because the Carrington Event itself, the benchmark we all fear, is not even the upper limit of what the sun can do. There are events written into the rings of ancient trees that dwarf it. Events so large that for a long time, scientists simply did not believe the sun was capable of them. We are going to dig into those buried records later, and they will change how you think about the word overdue. But first, we need to leave 1859 behind, because you might be tempted to think a disaster from the era of horse-drawn carriages has nothing to do with you. So let me show you what the sun has done to us recently, within the lifetime of almost everyone listening, and just how close we came to losing everything without most of us ever hearing a word about it. The night of March 13th, 1989, was bitterly cold across eastern Canada, and at just after 2:30 in the morning, 6 million people lost their electricity all at once. The cause was not a storm of snow or ice. It was a storm from the sun. A coronal mass ejection had struck the Earth, and in the frozen ground beneath the province of Quebec, the induced currents surged into the power grid run by the utility there. In the span of 92 seconds, less time than it has taken me to describe it, the entire grid collapsed. Protective systems tripped one after another in a cascade no one could stop, and a region the size of a country went dark in the dead of winter. People were trapped in elevators and pitch-black subway tunnels. The airport in Montreal lost power. It took about 9 hours to bring the lights back, and the people of Quebec were, in the grand scheme of things, lucky, because it was only 9 hours. That storm matters enormously to our story for one reason. It was far weaker than the Carrington event. I told you a moment ago that Carrington was somewhere between 1.5 and 3 times stronger than the storm that crushed the Quebec grid. Well, that was the storm. A storm, a fraction of Carrington's strength, reached into the modern world and switched off a major power grid in a minute and a half. The damage was not limited to Canada either. Far to the south, in the state of New Jersey, that same storm pushed its currents into a giant transformer at a nuclear power station and cooked it from the inside. That transformer was destroyed. Remember that detail about the transformer, because it is going to become the center of everything. If 1989 feels like a long time ago, come forward to the autumn of 2003, to a stretch of solar fury that space weather forecasters simply call the Halloween storms. Over the course of about 2 weeks, the sun unleashed a barrage of enormous flares, including one so powerful it overwhelmed the instrument trying to measure it, later estimated as one of the strongest flares ever recorded. The storms that followed reached down and damaged a transformer in South Africa, knocked out the power to tens of thousands of people in the Swedish city of Malmö, scrambled satellites, forced airlines to reroute flights away from the poles to protect passengers and crews from radiation and to keep their radios working, and disrupted navigation systems used by ships and aircraft. And all of that came from storms that, once again, were nowhere near the scale of 1859. There is an older case worth pausing on, because it sits squarely between the telegraph age and the modern grid, and it proves the danger never went away while we were busy electrifying. In the middle of May, in the year 1921, a tremendous geomagnetic storm swept across the planet, a storm now remembered as the New York Railroad Storm. It set fire to a railroad control tower in New York, burned out telegraph and signaling equipment across 2 continents, and threw the auroras far south once again. By some reconstructions, it was a meaningful fraction of the Carrington Event, perhaps the most intense storm of the entire 20th century. And here is the quiet lesson buried in it. The 1921 storm struck a world that was just beginning to wire itself for electricity, and it found more to break than 1859 had. Each storm landed on a more electrified planet than the last, and so each one had a little more of our lives to ruin. The hazard was not growing. We were simply building more and more for it to reach. So we have established a pattern that should genuinely unsettle you. Storms, much smaller than Carrington, have already broken pieces of our modern world, repeatedly, within living memory. But none of that is the part that should keep you up tonight. The part that should keep you up tonight happened on the 23rd of July in the year 2012, and most people have never heard a single word about it, which is exactly the kind of thing this channel exists to drag into the light. On that day, the sun erupted with a coronal mass ejection that, by the measurements we were able to take, was every bit the equal of the Carrington event. A monster. A storm of the precise magnitude that scientists had spent decades warning us about. It tore off the surface of the sun at a speed estimated between 2,000 and 3,000 kilometers every second, and it blasted straight across the path that the Earth travels around the sun. It crossed our orbit. It went right through the spot where our planet sits. And the only reason you are listening to me right now, with the lights on and your phone charged, is that the Earth had already moved on. We had passed through that exact point in space about 9 days earlier. The cannonball went through the place where we live, and we simply were not standing there. We missed a direct Carrington-class hit by roughly 1 week. We know all of this with such confidence for a remarkable reason. There happened to be a spacecraft, one of a pair called Stereo, positioned out in space, right in the line of fire, and it took the full blast and lived to send back the data. So, this is not speculation. This is not a story someone reconstructed from old newspapers. We have a precise, instrument-recorded measurement of a civilization-threatening solar storm passing through Earth's orbit in the modern era. The scientists who studied the data afterward concluded, in plain language, that if it had hit us, it would have produced effects comparable to, or worse than, the Carrington Event, against a world utterly unprepared for it. And here's the thing that should make the hair on your arms stand up. The reason most of us never heard about the 2012 near miss is not some grand conspiracy of silence. We will deal with the conspiracy theories later, and I promise you the real explanation is in some ways more disturbing than a cover-up. The reason you never heard about it is simply that nothing happened. There was no blackout to film, no city in darkness, no disaster to put on the news. The most dangerous solar storm of the modern age produced no headlines precisely because it missed, and a near miss is invisible. We were handed the clearest possible warning that the gun is loaded and pointed at us, and because no one got hurt, the world simply shrugged and moved on. So now, the real question sharpens into focus. If that storm had arrived 9 days earlier, what exactly would it have done to the machine we have built our entire lives inside of? To answer that, I have to show you the single most fragile, most irreplaceable, and most quietly terrifying object in modern civilization. There is a machine that you have almost certainly never thought about, that you will probably never see, and that your entire life, nonetheless, depends on completely. It is called a high-voltage transformer, and if you want to understand why a solar storm could end the world as we know it, you have to fall in love, just a little, with this deeply unglamorous hunk of steel and copper. Because the brutal truth is this: the lights in your home, the water in your tap, the food in your refrigerator, and the money in your bank account all rest on a small number of these machines, and they are almost perfectly designed to be destroyed by exactly the kind of storm we have been talking about. A power grid works by pushing electricity across enormous distances at extremely high voltage, because high voltage is the efficient way to move power over hundreds of miles of transmission line. Transformers are the machines that step that voltage up for the long journey and step it back down before it reaches your neighborhood. The biggest of them, the extra high voltage transformers that sit at the heart of the grid, are giants. A single one can weigh hundreds of tons, as much as a fully loaded passenger jet. And now, connect that to what we already know. A geomagnetic storm pushes those rogue currents, the geomagnetically induced currents, into the long transmission lines, and those lines funnel them straight into the transformers. Here's what happens next, and it is worth slowing down for, because this is the exact mechanism by which the sky reaches down and kills the grid. A transformer is built to run on alternating current, electricity that smoothly reverses direction many times a second. The current that a solar storm forces into it is different. It flows in one direction, like a steady shove, and that steady shove pushes the transformer's magnetic core into a state engineers call saturation. A saturated transformer can no longer do its job cleanly. It starts to overheat. It draws enormous, distorted bursts of power. Internal parts that are supposed to stay cool can reach temperatures hot enough to char their own insulation and melt their own copper. In a severe enough storm, the transformer does not just trip offline and wait to be switched back on. It is physically cooked. It is destroyed. And remember, this is not theory. This is precisely what happened to that transformer in New Jersey in 1989 from a storm a fraction of Carrington's size. Now here's where a bad day becomes a years-long catastrophe, and it all comes down to a single, devastating word: replacement. These giant transformers are not sitting on a shelf at a hardware store. Each one is essentially custom built for the specific spot in the grid where it lives. They are so large and so heavy that moving even one of them requires specialized railcars and months of planning. The factories that build them are mostly on the other side of the world, and even in normal times, the wait between ordering one of these machines and receiving it can run to a year or two. We keep only a small number of spare transformers in reserve. The entire system runs, in effect, with almost no backup. So walk through the nightmare with me, calmly, the way you would think through any real risk, because I am not interested in scaring you with fiction when the facts are frightening enough. A Carrington-class storm arrives and strikes the grid across an entire continent at once. Not one transformer saturates and burns, but dozens, perhaps hundreds, all in the same few hours. And now you cannot simply flip a switch to bring the power back, because the machines that make the power flow are slabs of melted metal. You need to replace them, but you needed dozens or hundreds at once. The factories can only build a handful at a time. The order book is already a year or two long, and the cranes and rail cars needed to install them require the very electricity that is now gone. The grid cannot easily rebuild itself, because rebuilding the grid requires a working grid. That is the trap. That is the house of cards. We did not just plug our civilization into the wall. We plugged it into a wall held up by a few hundred irreplaceable machines that a single bad day on the sun could turn to slag. This is not the fevered imagination of someone on the internet. This is the conclusion of sober institutions whose entire job is to think coldly about risk. A study commissioned by one of the oldest insurance markets in the world estimated that a Carrington-level storm striking the United States could leave somewhere between 20 and 40 million Americans without power, and not for 9 hours like Quebec, but for a span ranging from 16 days to as long as 1 or 2 years. With a total economic cost, they place somewhere between $600 billion and $2.6 trillion. A separate report from the United States National Academy of Sciences reached the same chilling conclusion about cascading failure across every system that depends on electricity. These are not doomsday preppers. These are actuaries and engineers, and they are telling you the house of cards is real. And yet you might still be tempted to file this under things that could theoretically happen but probably will not. The same mental folder where we keep asteroid impacts and supervolcanoes. That is the comfortable thing to do. It is also, I am sorry to say, exactly the wrong thing to do, because the timeline of these storms is not random reassurance. It is a clock. And when you actually look at how often the sun does this, and how long it has been since the last time, the word that comes out the other side is not unlikely. The word is overdue. To see why, we have to read a record far older than any telegraph, written in tree rings and ancient ice, and it tells a story about the sun that is genuinely hard to believe. For a long time, scientists believed the Carrington Event was about as bad as the sun could get. It was the worst storm in our records, so it became the ceiling of our imagination. And then, in the year 2012, a Japanese researcher named Fusa Miyake found something inside the rings of ancient trees that quietly shattered that ceiling and changed the question from how bad can it get to how are we still here. Here's the trick that makes it possible to read the sun's history in wood. When high-energy particles from space crash into our atmosphere, they create a slightly heavier radioactive version of carbon called carbon-14. Trees breathe in carbon from the air as they grow, and they lock a tiny amount of that carbon-14 into each year's ring. So a tree ring is, in effect, a yearly recording of how many cosmic particles were striking the Earth that year. Count back through the rings, measure the carbon-14, and you are reading a diary of the sky that stretches back thousands of years, 1 year per page. What Fusa Miyake found when she read the pages for the years 774 and 775 was a sudden, violent spike. In a single year, the amount of carbon-14 jumped far beyond anything that should be possible from the ordinary background of space. Something had bombarded the Earth with a flood of high-energy particles so intense that by some estimates it was an order of magnitude beyond the particle output of the Carrington Event. 10 times. And it was not a one-off fluke, because researchers went looking and found another enormous spike in the years 993 and 994, and then candidate events reaching much further back, into the centuries before recorded history. These spikes do not rest on tree rings alone. The same floods of particles leave a matching fingerprint in the layers of polar ice, in a different element called beryllium, laid down year by year in the snow of Greenland and Antarctica. When researchers line the tree record up against the ice record, the great spikes appear in both at the same moments on opposite ends of the Earth. That agreement is exactly why we trust them. Two completely separate archives, written by the same sky, telling the same story. We now call these monsters Miyake events, after the woman who first read them in the wood, and they have a sobering meaning. The sun does not just produce Carrington-class storms. Every so often, it produces something far larger, an outburst so violent that for years, many scientists refused to believe a normal star like ours was even capable of it. Now, I want to be careful and honest with you here, because honesty is the whole point of this channel, and the difference matters. A Miyake event is, as best we understand it, primarily a radiation event, an immense flood of particles, rather than a guaranteed grid-killing geomagnetic storm of the kind we have been describing. Whether a Miyake-scale event would also slam the ground with currents the way Carrington did is a genuine open question that researchers are still arguing over. So I am not going to stand here and tell you a Miyake event would definitely melt every transformer on Earth, because the science does not yet say that. What the Miyake events do tell you, with total certainty, is that the upper limit of the sun's violence is far, far above the storm we already know would devastate us. The thing we are afraid of, the Carrington event, is not the worst case. It is somewhere in the middle. So let us put the clock together, piece by piece, because this is the heart of the whole story, and I want you to be able to do the arithmetic yourself rather than just take my word for it. A direct Carrington-class hit appears to happen on the order of once every 100 to 150 years or so, on average. That is rough, and the sun does not keep an appointment book. But it is the best estimate we have from the historical and geological record. The last confirmed one was in 1859. Do the simple subtraction. That was about 165 years ago. We are sitting at the far end of the typical gap between these events, and every single year that passes without one does not make us safer. It nudges the odds the other way. One physicist put an actual number on it that has haunted me since I first read it. Analyzing the historical record, he estimated the chance of a Carrington-class storm striking the Earth at roughly 12% per decade. Sit with that for a second. 12% every 10 years. That is not a once-in-a-blue-moon, never-going-to-happen number. That is closer to the odds of a coin that comes up disaster a little more than one time in 10, and we are flipping it once a decade. Forever. Over a human lifetime, those odds stack up into something that stops looking like a remote possibility and starts looking like a near certainty waiting for its moment. And the Miyake events sit underneath all of it as a reminder that the rare, larger catastrophes are also out there in the deck, drawn perhaps once in 1,000 years or so, which sounds comfortably distant until you remember, we have no idea when the last card was dealt or when the next one comes up. This is what the word overdue actually means, and I want to strip it of any mysticism, because you will hear people use that word as if the sun owes us a storm on a schedule, and that is not what is going on. The sun owes us nothing and keeps no calendar. Overdue here is just the cold consequence of two facts standing next to each other. The first fact is that these storms recur on roughly a century timescale. The second fact is that it has been about a century and a half since the last big one. Put those together, and you do not get a prediction of next Tuesday. You get a loaded probability that grows heavier with each passing year, attached to a civilization that has spent that exact same century and a half making itself more dependent on electricity than any society that has ever existed. So if the threat is this real, and the odds are this stacked, and we have already had one clear near miss in living memory, you would assume we have thrown everything we have at preparing for it. You would assume there is a plan. And there is a plan, sort of, but the gap between the size of the threat and the size of our preparation is so wide that it raises an obvious and uncomfortable question. Why are we not ready? And that question is where the people who suspect a darker explanation start to speak up. So let us deal with them head on. Because some of what they say is nonsense, and some of it is closer to the truth than the official reassurances are. Whenever a threat is this large and this strangely ignored, people reach for the same explanation. They decide somebody must be hiding something. And I understand the instinct completely, because the gap between how dangerous this is and how little anyone talks about it really is bizarre. So let us walk through the theories one by one, honestly, and see which ones survive contact with the evidence. Because the answer we arrive at is, in my view, more unsettling than any cover-up. The first and most common claim is that the authorities already know a killer storm is coming, and they are keeping it secret to prevent panic. This one falls apart the moment you look at how space weather data actually works. The agencies that watch the sun publish their observations in close to real time, for free, to anyone with an internet connection. The spacecraft watching the solar wind stream their measurements out continuously. Amateur astronomers and aurora chasers around the world track this data obsessively and would notice in an instant if a giant cloud were inbound. There is no locked vault of secret solar data. If a Carrington-class storm left the sun tomorrow, it would be discussed openly within the hour by thousands of people who do not work for any government. The storm is the one part of this story that genuinely cannot be hidden. The second theory you will hear is that some technology on the ground, usually a research facility involving radio waves and the upper atmosphere, is somehow causing or steering these solar events. And I want to dispatch this one with simple arithmetic rather than mockery, because the arithmetic is decisive. A coronal mass ejection carries the energy of billions of nuclear weapons. Every transmitter, every antenna, every facility humanity has ever built, all of it added together, does not come within many, many orders of magnitude of that energy. Asking whether a ground-based transmitter could trigger or aim a solar storm is like asking whether you could change the course of a hurricane by blowing on it. The scale is not close. It is not even in the same universe. The sun does this entirely on its own, and nothing we possess can start it, stop it, steer it, or amplify it. The third theory is darker. The idea that a grid-down catastrophe is being deliberately engineered, that someone wants the lights to go out as a tool of control or population reduction. There is no evidence for this, and it actually runs backward against every incentive that exists. The people who run power companies make their money by selling power. Governments survive by keeping the lights on, not by switching them off. The real story, as we are about to see, is not that powerful people want this to happen. It is that fixing it is expensive and boring and politically invisible. And so it keeps getting pushed down the list. That is a far more ordinary failure than a grand plot, and far more believable. And the fourth, smaller claim worth touching is that the near miss in 2012 was hushed up. But it was not hushed up at all. The space agency that studied it actually went out of its way to publicize it a couple of years later, precisely to wake people up. The reason you never heard about it is not suppression. It is that a disaster that does not happen makes no sound, and our attention slides off anything that is not actively on fire. So if it is not a cover-up, and it is not a secret weapon, and it is not a plot, then what is the real answer to why we are so unprepared? Here is the part they really are not telling you, and it is not hiding in a classified file. It is hiding in plain sight, in budget meetings, and infrastructure reports that nobody reads. The truth is that hardening the grid against a solar superstorm would cost a great deal of money up front to protect against an event that might not arrive during any particular politician's term in office. Stockpiling spare transformers, installing devices that block these induced currents, and building the kind of resilient grid that could ride out a Carrington-class storm, all of it is achievable with known technology. We could do it. We mostly have not, because the threat is patient, and the budgets are not. And a danger that compounds quietly over decades is exactly the kind of danger human institutions are worst at confronting. That is the real conspiracy, if you want to call it one, and it is almost more frightening than the fictional versions, because there is no villain to catch and no secret to expose. There is only neglect, the slow, structural, deeply human habit of ignoring a catastrophe that has not happened yet. There are real efforts underway, I want to be fair, standards being written, forecasting being funded, some hardening being done. But the pace of that preparation and the size of the threat are not in the same league, and the clock, as we have seen, keeps ticking. Which leaves us with the question that actually matters to you, sitting where you are right now. Forget the trillion-dollar abstractions and the policy failures. What would the first 3 days actually feel like for an ordinary person if the storm we have been describing arrived tonight and the grid did not come back? Imagine the lights flicker once and then go out, and this time they do not come back in an hour or in 9 hours or by morning. To understand why a long blackout is so much more dangerous than the ones we are used to, you have to see how every system we depend on is secretly a chain, and how quickly those chains come apart when the first link, electricity, is pulled out. So let us walk through the first 72 hours, not to frighten you for sport, but because seeing the chain clearly is the first step to respecting how fragile it really is. In the first hour, honestly, it feels almost ordinary. The power is out. You have been here before. Phones still have charge, the water still runs, and there is food in the refrigerator. People assume it is a normal outage and settle in to wait. But underneath that calm, the clocks are already running. The cell towers that carry your phone signal have backup batteries that last only hours. The pumps that push clean water up into towers and through pipes are electric, and in many places the water keeps flowing for a while only because of pressure already in the system. The fuel in the gas stations sits in underground tanks, and the pumps that lift it out run on electricity. Nothing has failed yet that you can see. But everything that is keeping life normal is now running on a reserve that is quietly draining. By the end of the first day, the chain starts to snap link by link. The backup batteries on the cell network begin to die, and your phone, even with charge in it, finds no signal. The internet for most people goes with it. Now, you cannot call anyone, cannot look anything up, cannot find out how big the blackout is, or how long it will last. And that loss of information is its own kind of emergency, because fear grows fastest in the dark and the silent. The water pressure begins to fall as the pumps stay dead. The food in your refrigerator starts to warm, and the gas stations, even the ones with fuel still in the ground, cannot sell it, because the pumps will not run and the registers will not open, which means the cars stop refilling, which means the trucks stop moving. That last link is the one that turns a blackout into a crisis, because almost nothing you depend on is actually made near you. The food in every store arrived on a truck, usually just a day or two before you bought it, in a system built to keep almost nothing in reserve. When the trucks stop, the shelves are not restocked, and a modern store can empty in a couple of days once people realize the deliveries have ceased. Hospitals are running on emergency generators, but those generators need fuel, and the fuel needs trucks, and the trucks need working pumps. And so even the hospitals are on a countdown. Every system you would turn to in an emergency, water, food, fuel, medicine, communication, turns out to be a branch growing from the same single trunk, and that trunk is the electricity that is no longer there. Now stretch that picture out, not for 3 days, but for the weeks to months that the transformer problem implies, and you can see why the sober institutions used the language they did. This is the scenario behind that estimate of tens of millions of people without power for 16 days to a year or more. It is not the darkness itself that does the damage. It is everything the darkness switches off, and the fact that each switched off system makes it harder to turn the others back on. You cannot easily pump fuel without power, and you cannot easily restore power without fuel, and you cannot coordinate any of it without communication, which also needs power. The systems do not fail one at a time, politely. They fail into each other. There is also a layer of dependence almost no one ever sees, and a great solar storm reaches it directly. Much of the modern world is quietly synchronized by precise timing signals beamed down from navigation satellites. The same satellites a severe storm can scramble or degrade. Those signals do far more than tell your phone where you are standing. They stamp the timing onto financial transactions. They keep parts of the power grid itself marching in step, and they coordinate communication networks down to fractions of a second. A great storm can strike both ends of the chain in the same hours, the satellites overhead and the transformers underground, which means even the tools we would reach for to recover are wounded by the same blow. That is what sets this disaster apart from a hurricane or a flood. It does not strike one city and spare the next. It reaches the entire web at once, including the very threads we would use to climb back out. I want to step back from the edge for a moment, because this channel does not deal in despair, only in clear sight. None of this is a prophecy. Most of it could be blunted by exactly the preparation we talked about. The spare transformers, the protective hardware, the resilient design. And on a personal level, the same basic readiness that helps in any disaster. Some water, some food, a way to stay warm. A battery radio helps here too. The point of walking through the first 72 hours is not to leave you hopeless. It is to make one idea concrete and impossible to unsee. The reason a solar storm could end modern civilization is not that the sun is uniquely powerful. It is that we built a civilization where everything hangs from a single thread, and we did it without ever really looking up at the thing that can cut it. Which brings us back, in the end, to the sun itself, and to a final strange truth about the calm we are living in right now. Step outside tonight and look up, and the sun will have set on a perfectly ordinary day. The sky will darken in the usual way. The stars will come out, and there will be no sign whatsoever that anything is wrong. And that, after everything we have covered, is the most unsettling part of the entire story. Because the calm you feel is not evidence of safety. It is just the quiet before. The same quiet that hung over the world on the last day of August in 1859. And over Quebec in the hours before the grid fell. And over the Earth in the days before that monster cloud crossed our orbit in 2012 and found us already gone. We have traveled a long way together in this hour. So let me draw the thread all the way through. Because every piece of this points at one conclusion. The sun has not changed. It is the same star that set telegraph wires on fire when our grandparents' grandparents were young. The same star that knocked out a province in 92 seconds. The same star that fired a Carrington-class shot across our bow within the lifetime of most people listening. It throws these storms on a rough century time scale. It has been about 165 years since the last direct hit, and the odds, by the best estimate we have, run somewhere around 12% every decade and climb the longer we wait. The sun is not the thing that has become dangerous. We are the thing that has become vulnerable. Because here is the symmetry that I cannot stop thinking about, and that I want to leave with you. In 1859, the largest solar storm in recorded history hit a planet that barely noticed, because we had almost nothing electrical for it to break. In the time since, we have built the most extraordinary machine in human history, a global web of power and light and information that has lifted billions of lives and connected the entire species. And we built that miracle out of the one single material that a solar storm destroys. We took the thing the sun attacks, electricity in long wires and delicate circuits, and we made it the foundation of water, food, money, medicine, and memory. We did not just fail to protect ourselves from the storm. We rebuilt our whole world out of the one substance most exposed to it, and then we forgot to look up. And I want to be fair, one last time, because fairness is the difference between a warning and a scare. Overdue does not mean tomorrow. The storm might not come in your lifetime at all. The preparations that would blunt it are real and possible, and there are people working on them right now, quietly, against the indifference. A Carrington repeat would be a catastrophe, yes, but human beings are stubborn and resourceful, and a catastrophe survived is not the same as an ending. The title of this story is a warning written in the strongest possible ink, not a prophecy carved in stone. The honest claim underneath it is simpler and harder to dismiss. We have built a civilization that depends completely on a thread that the sun has cut before and will cut again, and we are not ready, and we know we are not ready, and we keep choosing not to get ready because the storm has not come yet. So the next clear night, when you look up at that calm and ordinary sky, I want you to feel two things at once. Feel the wonder of it. The fact that we live 93 million miles from a nuclear furnace whose quiet good behavior is the only reason any of this exists. And feel the weight of it. The knowledge that the same furnace has, more than once, breathed out a fire large enough to reach across all that empty space and touch the fragile electric web we have wrapped around our world. The storm is coming. Not tonight, maybe not for decades, but on a long enough clock, it is not a question of whether, only of when, and of whether we will have looked up in time. The sun has been patient with us. The terrifying thing about patience is that it always, eventually, runs out.